This is part 2 of the inverse functions videos. We're going to review the concept of inverse functions from the first video, use Desmos to look for patterns when graphing inverse functions, and then practice graphing them. So I've set us up with f of x equals 2 plus x divided by 3, and I'm going to fill out a couple rows of that table. So when x equals negative 2, y equals 0. When the input is negative 1, the output is 1/3. When the input is 0, the output is 2/3. And when the input is 1, the output is 1. When the input is 2, the output is 4/3. Okay, so we saw in the first video that the definition of an inverse function is a function that undoes the original. So because it's doing the opposite, we want to do the same operations but in the reverse order, and we want to do the inverse of each. So in f of x, we're taking x, we're adding 2, and then dividing by 3. So f inverse of x needs to take x, multiply by 3, and then subtract 2. And I can check this in a couple different ways. I could just fill out the table, but what I'm going to do is I'm going to choose my inputs carefully. So I'm going to choose the same inputs that I used, or that I got out as outputs in my f function. So I'm just taking all of these, and I'm just inputting them into my inverse function, or what I believe is my inverse function so far. So when I input x equals 0 to f inverse of x, I get 3 times 0 is 0, minus 2 is negative 2. 1/3 times 3, so 1/3 of 3 is 1, and 1 minus 2 is negative 1. 2/3 of 3 is 2, and 2 minus 2 is 0. 3 times 1 is 3, minus 2 is 1, and 3 groups of 4/3 is 4, 4 minus 2 is 2. So I see that the inverse function is doing the opposite of the original, and if I wrote out the information in these tables as coordinate points, I would see that the corresponding coordinate point is the same thing, but x and y are switched. The input and the output are switched. So negative 2, 0 becomes 0, negative 2. Negative 1, 1/3 becomes 1/3, negative 1, and so forth. And that's consistent with the way we were thinking about it in the last video as a function machine. So with the function machine, if I input negative 2, I get out 0, and going backwards we were inputting 0 and getting out negative 2. And so that's what our two tables are showing. Now we want to think about this in terms of graphing. So here's a graph of y equals 2x squared plus 1. And I can make a table of values for this. So I've got a couple coordinate points on my curve now, and I've got a table on the left side there. And I know that the inverse function is going to have the x and y, the input and the output, switched. So if I made a table of values, I could have my input and my output, and I would have 9, negative 2, 3, negative 1, 1, 0, 3, 1, and 9, 2. So if I wanted to graph those on my curve here, I could put 9, 2, and 9, negative 2, and then 3, negative 1, and 3, positive 1, and 1, 0. Okay, so I'm going to sketch my curve, and we need to see how we did now. So what I'm going to do is just go back and forth for a minute, because on the next slide I've got the inverse function graphed. So you can see up here that I graphed the inverse function by just switching the x and y in the equation. And when I go back and forth, you can see that we totally had the right curve graphed. Okay, so we want to notice a couple things. I'm going to go ahead and put those points back in where we have them. So 3, 1, and 3, negative 1, and then 9, 2, and I think that's enough for now. So positive 2, 9, which was right here, corresponds to 9, positive 2. Positive 1, 3 corresponds to 3, positive 1. This corresponds here, and this one corresponds here. Alright, so what we see is a definite pattern in the way these points are being transformed to become the inverse function. And what I'm noticing is that there seems to be some symmetry here. So if I went right down the middle of this graph, I've just graphed the equation y equals x. And you can see that I cut all of our purple arrows right in half and made this line perpendicular to all of them. So what's happening is these points are being reflected from their original across the line y equals x to get to their new point. So we want to see if that's a pattern that we notice in the next couple slides as well. So here's another example, y equals the square root of x minus 2 plus 3. So I can make a table to get some of my points mapped out. And then I want to just go ahead and switch the coordinate points. So I've got the point 2, 3, which is going to become 3, 2. I've got the point 3, 4, which will become 4, 3. Alright, I've got the point 6, 5, which will become 5, 6. I've got the point 11, 6, which will become 6, 11. So there's my curve. And I want to check to see that that was good. So it looks like I got the right curve. And I want to check to see if I see that same pattern as the last time. So I'm going to put in the graph of y equals x, and I want to look to see if the same thing is happening. So I've got the point 2, 3 becoming 3, 2. 3, 4 becomes 4, 3. The point right here I didn't have graphed, but notice that it doesn't move. So if it's on the line of symmetry, if it is being reflected, then it doesn't end up moving, which makes sense. So this point got moved to right here, and this point to right here. Alright, so we see that these points are being reflected across the line y equals x, and that's going to be a really useful method for drawing our own graphs. We can also use this as a little bit of a check. So let me erase all this stuff on here. And if I've got my sketch of the inverse function, I just want to make sure that I see some symmetry across that line. So if I look right here, I've got this little, kind of looks like tweezers, but that's a symmetrical shape. And then up here, I've got this, which is symmetrical across that line as well. So that's going to be my little check to make sure that I've done my sketches correctly. Looking at this, we've got a cubic function. And so what I need to do is first identify some coordinate points to shift. And so I've got this one here. I've got little maximums and minimums. The intercepts are going to be really nice, and I'll see if I have any lattice points. So here's one, the coordinate point negative 1, 2, and maybe I want to do that one, maybe I don't. So there we go. Okay, so I can get those points into my table, and I need to go ahead and switch the coordinate points. So negative 6, 0 becomes 0, negative 6. That maximum up there becomes 5.7, and then negative 3.6. So I'm estimating where I put this one. It's going to go about there. Negative 2, 4 becomes 4, negative 2. Negative 1, 2 becomes 2, negative 1. 0, 0 stays at 0, 0. Notice because that's on the line y equals x. When you switch the x and y, nothing changes. I want to sketch that minimum, so negative 1.7 and 1.6. So again, I'm estimating. 3, 0 becomes 0, 3. And 4, 4 stays right there because it's on the line y equals x. So this gives me enough of a picture to start to sketch. Okay, and I can check my work here. That looks pretty great. And once again, just putting in that line y equals x, I can see that the points that were on the line y equals x don't go anywhere. And I've got these little bits of symmetry here and here to check my work. Notice that when I graph the function to check it in Desmos, so I'm looking down here, I just plugged in the same exact equation, but I switched x and y. So I didn't write an inverse equation, which we learned to do in the last video. I just plugged it into Desmos with x and y switched, because that's how I know inverse functions work. And right now I'm just focusing on the graphing. So I would suggest when you do the practice problems that you start by drawing in that line y equals x, because right off the bat you're going to be able to get these points here that are on the line. You'll be able to just put those down knowing that they don't change when you invert the graph. Okay, and then pick a couple coordinate points that are easy to transform, switch x and y, graph them, and you need just enough that you can get the basic curve, the basic shape of the curve. Alright, so make sure you do those problem sets, and there's one more video coming on composition of functions to verify that they are inverses.